60 minutes of stellar spectacles, genetic revolutions, and the mysteries of the mind. Sci Sippers, buckle up for a celestial cocktail of mind-bending science served in a 1-hour scientific spectacle. Today's Sci Sips Binge Bonanza is a whirlwind tour of the universe's wonders, the potential of genetic engineering, and the enigmatic playground of our dreams. First, we're setting our sights on the star that sustains all life on Earth, the Sun. But despite its seemingly constant presence, the Sun holds many burning mysteries. We'll be venturing into the heart of this fiery ball of plasma, exploring the physics behind solar activity and uncovering the secrets that power our entire solar system. Imagine a nuclear furnace churning out enough energy to light up billions of planets. That's the Sun's incredible power, and we're going to unravel its secrets. Nature can be stranger than fiction, and sometimes life finds a way in unexpected places. Buckle up as we explore the bizarre phenomenon of virgin birth in fruit flies. Can an organism reproduce without fertilization? It turns out some species, like our tiny friends, the fruit flies, can pull off this seemingly impossible feat. We'll delve into the science behind parthenogenesis, explore its implications for our understanding of reproduction, and maybe even question what it truly means to be a parent. Ever witnessed a new star being born? We'll be front row seats for a nova revelation, a spectacular celestial event that transforms a star into a temporary blazing beacon in the night sky. Witness the awe-inspiring power of a star exploding, releasing more energy in a few seconds than our sun will in its entire lifetime. It's a cosmic light show unlike any other, and we'll be there to witness its fiery birth. Imagine being able to edit the very building blocks of life. We'll explore the revolutionary tool of CRISPR, a powerful gene-editing technology that holds immense promise for the future of medicine and agriculture. CRISPR allows scientists to precisely cut and paste sections of DNA, potentially leading to cures for diseases, the creation of hardier crops, and even the eradication of genetic disorders. We'll explore the ethical considerations and the exciting possibilities that CRISPR presents. The sun isn't the only fiery spectacle in space. Solar flares are explosive outbursts of energy that can disrupt satellites and power grids. We'll explore the science behind solar flares, their impact on Earth, and how we prepare for these fiery events. Understanding solar flares isn't just about protecting our technology, it's about understanding the sun's temper tantrums and how they can impact our planet. Finally, we'll delve into the world of dreams, those surreal, sometimes nonsensical journeys of the mind. What are dreams? Why do we have them? We'll embark on a scientific odyssey to unravel the enigma of dreams and explore the latest research into their purpose and meaning. From helping us process emotions to consolidating memories, dreams might be more important than we realize. 6 captivating topics in just 1 hour. Are you ready to quench your thirst for scientific knowledge in this epic binge watch? Hit that play button, grab your favorite cosmic beverage, and maybe a dream journal to document your adventures tonight, and let the scientific exploration begin. Don't forget to like, comment, and subscribe for more Sci Sips shenanigans. Remember, science is a never-ending journey of discovery, and this binge watch is your chance to join the adventure. So let's blast off.
Did you know that our sun, a seemingly ordinary star, is actually a celestial dynamo that converts 600 million tons of hydrogen into helium every second? Indeed, this radiant orb that hangs in our sky is far from ordinary. It is a G-type main sequence star, or what astronomers call a G-dwarf star, a classification that speaks volumes about its size, temperature, and luminosity. The Sun is a solitary entity in the cosmos, nestled comfortably in the Orion arm of the Milky Way galaxy. Yet, its influence extends far beyond its immediate vicinity. This is largely due to its colossal energy production, which results from the process of nuclear fusion. This intricate dance of atomic particles powers the Sun, transforming the simple hydrogen atom into the more complex helium. So in essence, our sun is a gigantic nuclear reactor, converting mass into energy at an astronomical scale. Delving deeper into the sun's core, we find an intricate ballet of particles governed by quantum mechanics and nuclear physics. This is not a dance choreographed by mere chance, but rather an enduring sequence of reactions known as the proton-to-proton chain. This chain reaction is the primary energy-producing process within our sun, a stellar forge that sustains life as we know it. The proton-proton chain begins with two protons colliding at high speeds. These protons, being positively charged, naturally repel each other due to the Coulomb barrier. However, a phenomenon known as quantum tunneling allows these protons to overcome this barrier and fuse together. This is where the magic happens. Quantum tunneling, a principle rooted in the world of quantum mechanics, permits particles to traverse seemingly insurmountable barriers. It essentially allows our sun's protons to get close enough to fuse into a heavier particle, a process that would otherwise be impossible. This fusion of protons forms a deuteron, releasing a positron and a neutrino in the process. The released positron soon encounters an electron, and the pair annihilate each other in a burst of energy, producing two gamma-ray photons. These photons trapped within the dense solar core may take a staggering 100,000 years to reach the sun's surface. During their journey, they are absorbed and re-emitted countless times, gradually losing energy and shifting from high-energy gamma rays to lower-energy visible light. Simultaneously, the neutrinos, virtually unimpeded by matter, zip straight out of the sun at nearly the speed of light. These elusive particles, detectable only through their weak interactions, offer us a real-time glimpse into the sun's fiery heart. Meanwhile, the deuteron collides with another proton, forming a helium-3 nucleus and releasing yet another photon. When two helium-3 nuclei collide, they fuse to form a helium-4 nucleus, releasing two protons and even more energy. This cycle repeats over and over, with each reaction contributing to the sun's ceaseless luminosity. Thus, the sun's radiance is a result of a convoluted dance of particles, a testament to the marvels of quantum mechanics. The sun's core is a subatomic stage where particles pirouette in a cosmic ballet, forging light and life in their wake. Our sun, like all stars, is on a journey of cosmic evolution, with a life cycle spanning billions of years. From its fiery birth in a nebula, through its vibrant youth and middle age, and into its peaceful twilight years, the sun's life is a tale of transformation, dictated by the inexorable laws of stellar physics. Stars, these celestial bodies, are born, live, and die just like living organisms. The sun, our very own star, is currently in its main sequence phase, the longest stage in a star's life. It's been burning hydrogen at its core for approximately 4.5 billion years, converting it into helium through nuclear fusion, a process that releases an immense amount of energy, warming our planet and making life possible. However, like all good things, this phase must come to an end. The sun's hydrogen supply is finite, and once depleted, our star will undergo a dramatic transformation. It will expand into a red giant, its outer layers swelling to such an extent that it could engulf the inner planets, including Earth. In this phase, the sun will be burning helium in its core, producing carbon and oxygen. After this turbulent red giant phase, the sun will shed its outer layers, leaving behind a dense hot core known as a white dwarf. This stellar remnant will slowly cool over billions of years. its once brilliant light fading into the cosmic background. Now you might wonder about the implications for our solar system when the sun exhausts its nuclear fuel. Well, the transition to a red giant will likely render Earth uninhabitable long before the sun becomes a white dwarf. The intense heat and radiation from the expanded sun would evaporate our oceans and strip away our atmosphere. Even in its eventual demise, the sun will continue to astound us, reminding us of the fleeting yet extraordinary nature of stellar life. This cycle of birth, life, and death is not unique to our sun. It's a cosmic ballet performed by all stars in the universe, a dance of energy and matter across the vastness of space and time. The sun does not exist in isolation. It profoundly influences our home planet and the rest of the solar system. Our radiant sun ceaselessly emits a stream of charged particles, a phenomenon known as the solar wind. This isn't a gentle breeze, but rather a turbulent, high-speed torrent with velocities reaching up to a staggering 800 kilometers per second. This solar wind is not uniform. It fluctuates, sometimes bursting into intense gusts which can have far-reaching impacts. In addition to the solar wind, our sun is also the source of other, more dramatic phenomena: solar flares and coronal mass ejections. Solar flares, the most powerful explosions in the solar system, release energy equivalent to millions of hydrogen bombs in a matter of minutes. Coronal mass ejections, on the other hand, are colossal eruptions of plasma, spewing billions of tons of the sun's outer atmosphere into space at incredible speeds. Now, these solar flares and coronal mass ejections, coupled with the constant solar wind, create what we refer to as space weather. This is not weather as we experience on Earth with its rain, wind, and snow, but a state of the space environment influenced by solar activity. Space weather can affect not only the solar system, but also extend its reach far beyond into the interstellar medium. The effects of space weather are not confined to the cosmos. They can also have significant impacts here on Earth. The interaction of solar wind with Earth's magnetosphere can lead to geomagnetic storms, which can disrupt power grids, interfere with satellite communications, and even pose a threat to astronauts in space. Furthermore, the energetic particles from solar flares and coronal mass ejections can cause spectacular displays of auroras, painting the polar skies with ethereal lights. But they can also pose a radiation threat, particularly for space-borne technologies and space travel. Indeed, the sun's influence is ubiquitous, shaping the space weather and casting its effects far into the cosmos. So, while we bask in its light and warmth, let us not forget the tremendous power and influence our sun wields both near and far. Our neighborhood of stars is a surprisingly sociable place. While vast distances separate them, by cosmic standards, they're practically next door. Here's a peek at some interesting neighbors of our sun. Alpha Centauri system. This triple star system, just 4.3 light years away, holds the title of closest star system to us. It's actually two main stars, Alpha Centauri A and B, orbiting each other closely, with a faint red dwarf, Proxima Centauri, farther out. Proxima Centauri is technically the closest individual star at 4.2 light years away. And it even has an exoplanet orbiting it, Sirius. This brilliant white dwarf, the brightest star in our night sky, might seem close at 8.6 light years away, but it's actually just a lone ranger passing by our neck of the woods. Sirius is fascinating because it has a white dwarf companion, Sirius B, which is the leftover cinder of a once massive star, Barnard's star. This tiny red dwarf, a mere 6 light years away, holds the record for the fastest proper movement across the sky of any star visible to the naked eye. Despite its proximity, it's too faint to see without a telescope. These are just a few of the interesting stars relatively close to our Sun. Our galaxy, the Milky Way, is teeming with billions of stars, each with unique properties and stories to tell. Our journey into the heart of the Sun reveals a celestial powerhouse, governed by the laws of physics and nuclear fusion. Let's revisit our cosmic voyage. We've delved into the Sun's core, the theater of nuclear fusion, where matter transforms into energy. We've journeyed through its life cycle, from stellar birth to a future white dwarf. We've witnessed its profound influence, shaping the solar system through solar wind and space weather. Scientists are trying to replicate this stellar process here on Earth to create a clean and virtually limitless source of energy, fusion power. Think about it. Clean. Fusion doesn't produce greenhouse gases or long-lived radioactive waste like nuclear fission. Limitless fuel. The fuel for fusion, hydrogen isotopes, deuterium and tritium, can be extracted from water, making it a practically endless resource. Abundant energy. A tiny amount of fuel can release a huge amount of energy, potentially solving our energy needs for centuries to come. However, achieving sustained fusion on Earth is a huge challenge. Scientists are working on creating and confining superhot plasma, charged particles, long enough for fusion to occur and generate more energy than what's put in. It's a complex scientific endeavor, but the potential rewards are so significant that research is constantly progressing. So the next time you look up at the Sun, remember? It's a giant ball of fusion power, and scientists are working hard to bring a piece of that star power down to Earth. So, while the Sun may seem ordinary, it is indeed a celestial dynamo. Its mysteries continue to captivate us, illuminating our understanding of the universe. If you're led by your curiosity, hit that like button and subscribe to Sci Sips for more stellar content. So, what do you say? Feeling starstruck? Smash that like button and subscribe to Sci Sips for more cosmic adventures. Let us know in the comments. What's the coolest fact you learned about stars today?
You're scrolling through TikTok, minding your own business, when suddenly a video pops up of a fly laying eggs. But here's the crazy part. There's no fly dad in sight. Apparently, scientists just made flies become superheroes of singledom, reproducing without needing a mate. Is this the end of bros for these flies? Are we next? We'll crack open that question in a sec, but first, let's smash that like button and dive into the weird world of fly virgin births. Imagine a world where the birds and the bees tale no longer holds true, where reproduction no longer requires a partner. Today, we delve into a scientific breakthrough that alters the course of biology as we know it. Welcome to the world of parthenogenesis. The phenomenon of virgin birth, or parthenogenesis, has been observed in various species throughout nature. In this process, an egg develops into an organism without being fertilized by a sperm. However, until recently, the genetic basis of this process remained elusive. Researchers from Cambridge University and the California Institute of Technology have achieved a significant breakthrough by developing a sexually reproducing fruit fly species capable of reproducing asexually. They have identified and manipulated 3 genes that enable reproduction without sperm from a father, a process known as facultative parthenogenesis. This groundbreaking study has shed light on the genetic basis of virgin birth and its potential implications for crop pests and food security. By manipulating the genetic composition of fruit flies, about 11% were able to reproduce without a male partner. This form of reproduction is believed to be a survival strategy in response to unfavorable conditions. Here's how this works. Firstly, scientists studied a fruit fly species, Drosophila mercatorum, known for parthenogenesis. They compared its genes to those of Drosophila melanogaster, the common lab fly that normally requires sexual reproduction. This helped pinpoint 44 genes potentially involved in parthenogenesis. Next, researchers altered the equivalent genes in D. melanogaster. This involved editing the fly's DNA to mimic the genetic state found in the parthenogenetic species. Then, by altering various combinations of genes, scientists identified a specific combination that induced parthenogenesis in roughly 11% of female D. melanogaster. These modified females could develop viable eggs without mating. It's important to note that this process isn't perfect. The offspring weren't always identical clones of the mother because some genetic reshuffling still occurred. Additionally, these virgin-born flies retained the ability to reproduce sexually if mated with males. The ability for virgin birth was passed down to following generations, but only manifested when no males were present for mating. Now, some of you might be wondering if this means we're on the cusp of human virgin births. Hold on to your lab coats. While this research is fascinating, it's important to remember the key difference between science fiction and reality. Right now, human reproduction relies heavily on both sperm and egg, and there's no evidence to suggest we can switch that up anytime soon. But here's the exciting part. This discovery in fruit flies is a giant leap forward in understanding the intricate mechanisms of reproduction across different species. It opens doors to exploring how some animals choose sexual reproduction or parthenogenesis, and perhaps even how these strategies might evolve in the future. In the grand scheme of evolution, this research provides valuable insights into the genes involved in parthenogenesis and highlights the potential impact of modern agricultural practices on inducing virgin births in crop pests. While the common housefly, Musca domestica, might be a buzzing annoyance, it's actually a pretty impressive insect when it comes to science. There isn't just one housefly. The family Muscidae encompasses over 5,000 described species. Some interesting members include stablefly, Stomoxys calcitrans. These persistent biters target animals, not food scraps, and can transmit diseases like sleeping sickness. Vasefly, Musca autumnalis. These guys love hanging out around our faces, attracted by sweat and tears. Fruit fly, Drosophila melanogaster. This famous lab favorite isn't technically a housefly, but it belongs to the same family and shares some similar characteristics. Houseflies, particularly the common housefly and fruit fly, have been instrumental in various genetic experiments due to several reasons. Short lifespans. Their rapid reproduction allows scientists to study multiple generations in a short time frame. Relatively simple genetics. Compared to more complex organisms, their genetic makeup is easier to manipulate and understand. Fast mutation rates. Houseflies readily develop resistance to insecticides, making them ideal for studying how genes influence these adaptations. Here are some key areas where houseflies have contributed to scientific progress. Genetics basics. Fruit flies like Drosophila melanogaster helped unlock fundamental principles of inheritance, paving the way for modern genetics research. Evolution in action. Studies on housefly resistance to insecticides demonstrate how natural selection can drive rapid evolution in response to environmental pressures. Disease transmission. Research on houseflies helps us understand how they transmit diseases like dysentery and typhoid, informing public health measures. So, as we stand at the precipice of a new era in genetic engineering, we contemplate the marvels of science that allow us to manipulate the very essence of life. We realize that the future of biology and genetics is teeming with possibilities that lie far beyond our current comprehension, and we eagerly anticipate the discoveries that lie just beyond the horizon. In the end, the manipulation of fruit flies for virgin birth is not just a scientific curiosity. It's a testament to our ever-growing understanding of the genetic code, a beacon of light in the vast ocean of biological mysteries. Fruit flies genetically engineered for virgin birth. The culmination of years of research, a testament to human ingenuity and a glimpse into a future where the rules of reproduction are rewritten. And so, the story of life continues to evolve in ways more mysterious and fascinating than we could ever imagine. And with that, we bid you farewell. Until our paths cross again in this journey of unraveling the mysteries of our existence. Did this video leave you buzzing with curiosity? So are flies the ultimate singles or what? Smash that like button and subscribe to Sci Sips for more mind-blowing science. We'll be diving deep into all sorts of fascinating topics, so hit that subscribe bell to never miss an episode.
A star's life begins in a giant cloud of gas and dust, mostly hydrogen, called a nebula. Within the nebula, gravity causes clumps of material to condense and heat up. As the clump gets denser and hotter, it eventually reaches a point where nuclear fusion ignites in its core, marking the birth of a star. Ever wondered how the universe gets its bling? No, seriously, those dazzling stars that light up the night sky, where do they even come from? Believe it or not, they weren't always those balls of burning gas we see today. They started in let's just say a cosmic dust bunny the size of a city. Prepare to have your mind blown as we journey to the stellar nursery and witness the explosive birth of a star. Buckle up because things are about to get hot. Picture this: a binary system, a white dwarf and a red giant star cohabitating in the constellation of Corona Borealis. The white dwarf, akin to a cosmic vampire, siphons off matter from its red giant companion. This material accumulation, primarily hydrogen, forms an accretion disk around the white dwarf, spinning and swirling in a mesmerizing cosmic waltz. The pressure and temperature within this disk rise exponentially, setting the stage for a spectacular event. This mounting pressure triggers a runaway thermonuclear reaction on the surface of the white dwarf. The energy released is so immense that it causes an outburst of light, akin to a hydrogen bomb detonating in space. This is a nova, a temporary new star that outshines its surroundings, and in the case of the T Coronae Borealis system, is predicted to brighten to a level comparable to Polaris. While scientific understanding of stellar birth is recent, many cultures have rich mythologies and traditions surrounding the appearance of new stars in the night sky. Here's a glimpse into some fascinating examples. Ancient interpretations. Native American. Many tribes associated new stars with creation events. The Iroquois believed a new star signaled the birth of a new spirit into the world. The Lakota people saw them as signs of change or upheaval. Chinese new stars were seen as omens interpreted by astrologers. A bright new star might signify the birth of an emperor or a period of prosperity. A dimmer one could be a warning of war or famine. Ancient Greece, the appearance of a new star was often linked to heroes or gods. The constellation Cassiopeia, for instance, tells the story of a vain queen who was punished by being placed in the sky forever. Modern-day supernova watch parties. Professional and amateur astronomers hold supernova watch parties, where they gather to observe galaxies known for stellar explosions. Spotting a supernova is a rare but thrilling event. Wishing on a star. This widespread tradition, particularly popular with children, reflects the enduring human tendency to see stars as sources of luck, wishes, and guidance. Despite cultural differences, there are some common themes. Change and transformation. The appearance of a new star often signified a significant change or event on Earth. Divine connection. Stars were seen as connected to the gods or the spirit world, offering messages or omens. Awe and wonder. The vastness and mystery of the cosmos have always inspired awe in humans. New stars served as a reminder of the power and beauty of the universe. The recurrence of this nova, once every 80 years, is a cosmic spectacle. The last eruption in this system was in 1946, and the next one, anticipated between now and September, will be visible from the Northern Hemisphere for a fleeting period before dimming. This rare occurrence offers an invaluable opportunity for scientists to study the complexities of binary systems and the mechanics of nova events. So, let's recapitulate. A nova event occurs when a white dwarf in a binary system accumulates matter from its companion star, causing a thermonuclear reaction. This results in an eruption, visible as a temporary new star. The T Coronae Borealis system, located in the Corona Borealis constellation, is set to exhibit such an event, which recurs approximately every 80 years. The brightness of this outburst is expected to rival that of Polaris. The rarity and significance of this event cannot be overstated. Most nova eruptions have cycle times longer than 1,000 years, making the T Coronae Borealis nova a unique cosmic spectacle. This event, a testament to the dynamic and ever-changing universe we inhabit, offers a rare glimpse into the intricate ballet of the cosmos. The Large Hadron Collider, LHC, isn't exactly creating new stars here on Earth, but it is replicating some of the extreme conditions that existed in the early universe, just moments after the Big Bang, when stars were first starting to form. Here's how. Recreating the early universe. Superheating protons. The LHC smashes beams of protons together at incredibly high energies close to the speed of light. This collision recreates the superhot, superdense environment that existed in the first fraction of a second after the Big Bang. Not quite stars, but fundamental soup. While the LHC doesn't create self-sustaining fusion reactions like stars, it does produce a short-lived soup of fundamental particles that haven't been seen since the early universe. Wonderful discoveries so far. The Higgs boson. A major discovery of the LHC was the Higgs boson in 2012. This particle helps explain why other particles have mass, which is crucial to our understanding of the universe's basic building blocks. Beyond the standard model, the LHC is searching for evidence of particles and forces not predicted by the standard model of physics, our current understanding of fundamental particles and forces. These discoveries could revolutionize our knowledge of the universe. As we conclude, remember, we are passengers on an incredible journey, traversing through the cosmic ocean, witnessing the grandeur of the universe unfold. The Nova event serves as a reminder of the universe's might and mystery, a testament to the ceaseless cosmic ballet. Don't forget to explore our videos about our most beloved star, our very own sun. Enjoyed this cosmic adventure? Smash that like button and let us know in the comments what stellar topics you'd like to see next. Subscribe to Sci Sips for more mind-blowing science.
Imagine a world where diseases are edited out of existence, crops grow bigger and stronger, and the very building blocks of life are within our control. This isn't science fiction. This is the brave new world of CRISPR. For years, scientists have dreamt of editing genes with precision. Now, thanks to a revolutionary tool found hiding in bacteria, that dream is becoming a reality. CRISPR isn't some clunky machine or vat of bubbling chemicals. It's a clever trick bacteria use to fight off viruses, and we've turned it into genetic editing superpowers. Are you ready to dive into the future? Buckle up, because we're about to explore the incredible world of CRISPR, the tool that's rewriting the code of life. In the annals of medical science, few discoveries have sparked as much excitement, potential, and controversy as CRISPR. Our journey takes us back to the early 20th century, to the birth of bacteriophage technology. These viruses, which prey exclusively on bacteria, became the unsung heroes of genetic research. By studying their interactions with bacteria, scientists unlocked the secrets of DNA manipulation. This was the genesis of genetic engineering. As the decades rolled by, this nascent field began to mature, setting the stage for a series of groundbreaking breakthroughs. Among these, the advent of recombinant DNA technology in the 70s proved pivotal. This technique allowed scientists to splice together DNA sequences from different organisms, creating a whole new world of possibilities. It revolutionized pharmaceutical manufacturing, enabling us to produce life-saving drugs like insulin and growth hormone in large quantities. However, these techniques, as innovative as they were, had their limitations. They were often imprecise, laborious, and time-consuming. The world of genetic engineering yearned for a tool that was precise, easy to use, and versatile. And in the early 21st century, that tool arrived in the form of CRISPR. CRISPR, short for clustered, regularly interspaced, short palindromic repeats, is a system borrowed from bacteria. It's their defense mechanism against bacteriophages. But for us, it's a molecular scalpel, capable of making precise cuts in the DNA sequence. It's like a text editor for the genome, allowing us to add, remove, or change specific parts of the DNA sequence. This revolutionary tool has transformed the landscape of genetic engineering. It has made gene editing faster, cheaper, and more precise than ever before. It has opened up a new universe of possibilities, from curing genetic diseases to enhancing agricultural productivity and creating biofuels. But it has also raised a host of ethical and regulatory concerns, forcing us to grapple with the profound implications of our newfound power. The dawn of CRISPR has opened a new chapter in genetic engineering, a chapter filled with immense potential and profound questions. CRISPR, in its elegant simplicity, is a masterstroke of nature's engineering. This revolutionary technique allows for precision editing in the genetic code of life, akin to a molecular scalpel. Our journey through the mechanics of CRISPR begins with guide RNA design. Crafted in the lab, the guide RNA is a custom-made courier, its sequence of nucleotides designed to match a specific location within the vast labyrinth of an organism's DNA. Its mission? To guide the Cas9 protein to the correct address within the genome. Next enters the Cas9 protein delivery. Cas9, the molecular scissors of the CRISPR system, is introduced into the cell. This enzyme is a marvel of nature, capable of being transported across the cell membrane and navigating the crowded cellular environment to rendezvous with the guide RNA. The magic unfolds with target DNA recognition. The guide RNA, bound to the Cas9 protein, scans the DNA, searching for its match. When it finds the complementary DNA sequence, it binds, holding the DNA in place. The climax of this intricate dance is the DNA cleavage. The Cas9 protein, now firmly anchored, makes a precise cut in the DNA strand. This cut is not random but meticulously calculated, aimed at a specific gene or genetic sequence. But nature abhors a break, especially in something as vital as DNA. This leads us to the final act, DNA repair. The cell, in its infinite wisdom, recognizes the breach and rushes to mend it. However, during this repair process, scientists can introduce a new genetic sequence, effectively rewriting the genetic code. This is the elegance of CRISPR, a system that harnesses the cell's own machinery to enact change. Each step, from guide RNA design to DNA repair, is a testament to the ingenuity of scientific exploration and nature's own engineering prowess. Thus, CRISPR stands at the frontier of genetic manipulation, a powerful tool in the hands of science. The applications of CRISPR extend far beyond the confines of a laboratory. Its potential is truly staggering. Consider gene therapy, where CRISPR offers hope for treating, perhaps even curing, once intractable genetic diseases. Imagine a world free from the chains of cystic fibrosis, muscular dystrophy, or sickle cell anemia. But the promise of CRISPR doesn't end at our own genome. Its influence extends to the very food on our plates. By precisely editing the genes of crops, we can create plants that are more nutritious, more resistant to pests, and better able to withstand the rigors of climate change. And let's not forget biofuels. By tweaking the genes of algae and other organisms, we can produce cleaner, more efficient fuels that could help combat the looming threat of global warming. Yet, with such monumental power comes the potential for misuse. The prospect of home-based genetic tweaking is tantalizing, but it underscores the urgent need for thorough regulation and oversight. CRISPR, thus, holds the promise to reshape our world, one gene at a time. With great power comes great responsibility, and CRISPR is no exception. In the age of gene editing, the ethical and regulatory concerns are as vast and complex as the technology itself. The potential for misuse of CRISPR technology is a reality we cannot ignore. Imagine a world where genetic modifications are not limited to curing diseases, but extend to designing our offspring with desired traits, a practice known as germline editing. The dystopian idea of designer babies is no longer confined to the realms of science fiction. Moreover, this technology could be exploited for malicious purposes. The potential for creating dangerous organisms or bioweapons is a chilling prospect that underscores the urgent need for stringent oversight. Yet the very power of CRISPR that can be misused also holds the promise to eradicate genetic diseases, enhance crop yield, and address myriad environmental issues. So, how do we balance the potential benefits with the potential risks? This conundrum has sparked intense debates within the scientific community. Some advocate for a moratorium on certain uses of the technology, while others argue for the need of a robust ethical framework that evolves with the technology. The stakes are high, and the decisions we make today will reverberate through generations to come. The question is not whether we should use CRISPR, but how we should use it responsibly. The regulatory landscape is evolving, albeit slowly. In many countries, laws and guidelines are being formulated to govern the use of CRISPR. However, these regulations vary greatly across borders. and are often outpaced by the rapid advancements in the field. This underscores the need for international cooperation. A globally coordinated effort is required to establish universal ethical norms and regulatory standards. As we stand on the precipice of a genetic revolution, the way we wield the power of CRISPR will shape not just our future, but the future of life itself. We must tread this path with caution, wisdom, and a deep sense of our shared responsibility. CRISPR's potential goes far beyond fixing diseases. Here are some mind-blowing examples. Scientists used CRISPR to insert genes for bioluminescence, glowing, from jellyfish into pigs and plants. Imagine glowing houseplants or medical imaging with bioluminescent cells. Researchers are using CRISPR to edit genes in mosquitoes that make them resistant to the parasite that causes malaria. This could be a game changer in the fight against this deadly disease. Scientists are exploring using CRISPR to insert mammoth genes into Asian elephant cells to create a cold-resistant hybrid, a controversial attempt at de-extinction. CRISPR is being used to develop crops that are drought-resistant, more nutritious, or even produce biofuels. Imagine super rice needing less water or corn with built-in vitamin A. Scientists are using CRISPR to engineer bacteria that can kill antibiotic-resistant superbugs, a potential solution to a growing global health threat. Whoa, that was a mind trip. Thanks for joining us on this exploration. Did you learn something new about CRISPR? If you enjoyed this video, consider subscribing to Sci Sips for more in-depth dives into the fascinating world of science. Let us know in the comments what other science stuff you'd like to see.
Imagine a giant fireball millions of times bigger than Earth. Now, picture it erupting with a ferocious burst of energy, a blinding flash that could outshine 1 billion suns combined. This, my friends, is a solar flare, a celestial dance of fire and magnetism playing out on our very doorstep. But these fiery outbursts aren't just a light show. They can unleash a torrent of charged particles that races across the solar system. And guess what? Earth is right in its path, so buckle up, because in this video we're diving deep into the heart of a solar flare to unravel its secrets and discover how it can impact our world. In the cosmic theatre of our universe, the sun recently played a rather dramatic act. In the otherwise serene celestial landscape, a sudden lash of energy painted a vivid scene, an M7, 4-class solar flare, a magnificent spectacle of Mother Nature's fiery temperament. On the 10th day of March, a rather unassuming protagonist, sunspot AR 3599, took center stage. In an unexpected twist, it unleashed a powerful solar flare, a burst of electromagnetic radiation triggered by a buildup of magnetic energy in the sun's atmospheric layers. This solar tantrum led to an extensive radio blackout across the vast expanses of Africa and the South Atlantic for up to 30 minutes. Accompanying this flare was a coronal mass ejection, or CME for short, a significant release of plasma and accompanying magnetic field from the solar corona. Traveling at a staggering speed of 1.7 million miles per hour, the CME is predicted to pass ahead of Earth, potentially causing minor geomagnetic storm conditions. The GOES, geostationary operational environmental satellites operated by NOAA, National Oceanic and Atmospheric Administration, are the primary instruments used to measure solar X-rays. These satellites are positioned in a geosynchronous orbit, allowing for continuous monitoring of the sun. Yet, the solar drama didn't end there. On March 17th, another CME erupted from the sun, heading towards Earth and potentially causing another geomagnetic storm. NASA's Solar Dynamics Observatory recorded this CME, intriguingly dubbed a canyon of fire, expected to graze Earth's magnetic field on the 20th of March. This upcoming geomagnetic storm holds the potential to instigate auroras in high latitudes, coinciding with the vernal equinox and the Russell-McFerran effect, which renders Earth's magnetic field vulnerable to even minor solar winds during this period. Solar flares, in essence, are intense bursts of energy associated with sunspot groups typically occurring in active regions of the sun. They are classified into distinct categories: X-class flares being the most powerful, followed by M-class, C-class, B-class and A-class flares. The recent solar flare was classified as an M7, 43, a powerful flare in its own right. The Sun, our life-giving star, recently demonstrated its unpredictable and tempestuous nature. The sudden burst of an M7 4-class solar flare from sunspot AR 3599, followed by a fast-moving CME, has set the stage for potential geomagnetic storms on Earth. Coupled with the upcoming Canyon of Fire CME, we may witness enchanting auroras at high latitudes, a celestial ballet orchestrated by the intricate interplay between solar activity and Earth's magnetic field. Solar flares, while impressive displays of the Sun's power, can have a mixed bag of effects on Earth. Here's a breakdown of and negative impacts. Radio blackouts. Strong flares can disrupt radio waves in the Earth's ionosphere, hindering communication for everything from airplanes to emergency services. This can last from minutes to hours. GPS glitches. The accuracy of GPS signals can be affected by solar flares, impacting navigation systems for both civilian and military use. Power grid damage. In extreme cases, a powerful solar flare can induce strong currents in power grids, overloading transformers and causing widespread blackouts. The Carrington event of 1859 is a historical example, causing sparks to fly from telegraph lines. Satellite disruptions. The increased drag from a heated atmosphere due to solar flares can shorten the lifespan of satellites in low Earth orbit. Additionally, sensitive electronics on board can be damaged by the radiation burst. We previously covered methods of communication that could be useful in the event of an internet blackout, LoRa and LoRaWAN. But these technologies are also not immune to solar flares and may be disrupted temporarily. Do you wonder how man-made objects in space survive these onslaughts? Satellites and the International Space Station, ISS, have varying levels of protection against solar flares due to their location and design. The biggest advantage for both ISS and many satellites is their location in low Earth orbit. They benefit from the protection offered by Earth's magnetosphere, a giant magnetic field that deflects most of the charged particles released during a solar flare. In addition, many satellites are designed with special shielding around critical electronic components. This shielding can be made from aluminum or other materials that absorb or deflect radiation. The specific type and amount of shielding used depends on the satellite's function and its expected exposure to radiation. The ISS has specific modules designed to provide shelter for astronauts during a solar flare event. These modules have thicker walls made of aluminum and other materials to offer superior radiation protection. There are currently no ways to completely prevent humans from being affected by solar flares, as these are natural phenomena. However, there are several measures being taken to mitigate the risks and protect human infrastructure. Space weather monitoring. A global network of telescopes and satellites continuously monitors the Sun for signs of solar activity. This allows for early warnings of potential flares, giving us time to prepare. International collaboration. The National Oceanic and Atmospheric Administration, NOAA, in the US, works with similar agencies worldwide to share data, forecasts and warnings about solar storms. Power grid upgrades. Utilities are exploring ways to strengthen the power grid against the effects of solar flares. This could involve installing special transformers that can withstand surges caused by induced currents, or developing alternative power distribution systems less vulnerable to geomagnetic storms. The military is particularly reliant on satellites and communication systems. They are actively researching and implementing measures to ensure their continued operation during solar events. This might involve hardening electronic components or having backup systems in place. Government agencies are developing emergency response plans for dealing with the aftermath of a major solar storm. This could involve prioritizing critical infrastructure repairs, ensuring communication channels remain open, and managing potential disruptions to essential services. Educating the public about the potential risks of solar flares and basic preparedness steps can help individuals and communities cope with the effects of a solar event. This could include stocking up on emergency supplies, having alternative communication methods available, and following official instructions during a solar storm. As we continue to gaze upon the cosmic theatre, we're reminded of the sun's mercurial temperament and the captivating drama it plays out. A drama filled with solar flares, CMEs, radio blackouts, and geomagnetic storms. A drama that, while grounded in the realm of science, still manages to retain an air of mystery and intrigue. Solar flares got you curious? Like this video and subscribe to Sci Sips to stay informed about all things space.
Ever woken up drenched in sweat, heart pounding, after a dream so real it felt like you lived it? Or maybe you've soared through the sky, defied gravity, and done things your waking self could only dream of. What are these bizarre journeys of the mind? Are they messages from the subconscious? Portals to alternate realities? Or just our brains on sleep? Tonight on Sci Sips, we're ripping back the veil of mystery and diving headfirst into the science of dreams. Buckle up, Sci Sippers, because it's going to be a wild ride. Have you ever wondered why we dream? These nightly fantasies, vivid, bizarre, and sometimes utterly perplexing, have intrigued humanity for millennia. From the ancient Egyptians, who considered dreams as glimpses into the supernatural realm, to the Greeks, who perceived them as divine messages, dreams have been a subject of fascination and mystery. Even in our modern age, they remain an enigma, an elusive realm where science and mystery intertwine. The early philosophers and scientists sought to decode these nocturnal narratives. They speculated on their origins, their purpose, and their potential significance. Some believed dreams to be reflections of our deepest desires. Others saw them as warnings from the subconscious mind, and yet others viewed them as mere random firings of the brain during sleep. As we delve into the science of dreams, prepare for a journey that will take us from the deepest recesses of our minds to the very edge of consciousness itself. To comprehend the science of dreams, we must first understand the architect of these nightly visions, the human sleep cycle. This biological rhythm, a masterwork of nature, is a symphony in 4 movements, each corresponding to a specific stage of sleep. The overture commences with light sleep, a fleeting prelude that gently lulls us into the realm of dreams. As the melody progresses, we delve deeper into a state of profound tranquility known as deep sleep. It is in these initial stages that our bodies rejuvenate, healing and restoring themselves for the day ahead. Yet the true artist behind our dreams is the 3rd movement, the rapid eye movement stage, or REM sleep. Here, the brain teems with activity, rivaling, sometimes even surpassing, the bustle of our waking minds. In this stage, neurons blaze with electrical signals, forming intricate electroencephalogram patterns that dance like staccato notes on a conductor's score. Simultaneously, a neurotransmitter named acetylcholine floods our neural pathways, triggering vivid hallucinations that we perceive as dreams. This surge, coupled with a heightened cortical activation, blurs the boundaries between sleep and wakefulness, creating a surreal world where our wildest fantasies come to life. As we surrender to slumber, our brain orchestrates a symphony of activity, setting the stage for the dreamscape to emerge. In the stillness of the night, we become the audience to an extraordinary performance, a nightly spectacle crafted by the architect of dreams. Now that we've explored the stage, let's turn our attention to the playwright of our dreams, the subconscious mind. The playwright of dreams, the subconscious, is a master storyteller, crafting narratives from the material of our lives. It's a realm where our deepest fears, desires, and experiences are given form, a reflection of our innermost selves. Psychoanalysis, a field pioneered by Freud, posits that dreams are a gateway into the subconscious, a way for buried thoughts and feelings to surface. Our subconscious mind, like a playwright, uses these dreams to communicate with us, often in symbols and metaphors. Dreams are also a testament to the intricate cognitive processes at work, even as we rest. Our neural networks, the interconnected pathways of neurons in our brains, work tirelessly, processing information from the day, forming connections, and consolidating our memories. Dreams in this context can be seen as the byproduct of these cognitive processes, a nightly rehearsal of the experiences and information we've encountered. But, as with any great playwright, the subconscious mind leaves room for interpretation. The narratives it weaves in our dreams are as unique as we are. They're personal, subjective, and often enigmatic, requiring thoughtful analysis and introspection to decode. So while the science of dreams is grounded in neurobiology and psychology, it also ventures into the realm of mystery and subjectivity. Each dream is a personal journey into the subconscious, a nightly voyage into our innermost selves. In the theater of dreams, our subconscious mind takes center stage, weaving tales that are as revealing as they are enigmatic. Imagine being able to control your dreams, to become the director of your own nocturnal narratives. This is the realm of lucid dreaming. Lucid dreaming, a state of consciousness where one is aware they're dreaming and can influence the course of their dream, is a fascinating blend of sleep and wakefulness. This phenomenon has piqued the interest of neuroscientists and psychologists alike, as it offers a window into the workings of our mind during sleep. The science behind lucid dreaming is as intriguing as the concept itself. It is believed that the phenomenon is associated with heightened metacognition, or the ability to think about one's own thinking. This self-reflection is linked to increased activation in the prefrontal cortex, an area of the brain responsible for higher cognitive functions and self-awareness. The potential benefits of lucid dreaming are vast. It can serve as a therapeutic tool for tackling nightmares, phobias, and even rehearsing real-life scenarios. On the flip side, there are potential risks to consider. Some individuals may experience sleep disruption or blurred boundaries between reality and dreams, which could potentially lead to psychological distress. However, it's crucial to remember that the field of lucid dreaming is still in its infancy. While we've made strides in understanding the science behind it, much remains to be uncovered. In the world of lucid dreaming, the line between the dreamer and the dream blurs, opening up a world of limitless potential. In the quest to unlock the power of dreams, even the CIA has shown interest through their Gateway program. This clandestine initiative, shrouded in secrecy and intrigue, aimed to harness the potential of human consciousness. Its purpose, to explore altered states of consciousness and the phenomenon of remote viewing. The Gateway program utilized a technology known as HemiSync, a patented audio technology designed to facilitate altered states of consciousness. By inducing a state of hemispheric synchronization, or hemisync, the CIA hoped to unlock the latent powers of the human mind, including the ability to remote view or perceive locations, people, and events from a distance. The implications of this technology for dream research are profound. Imagine, if you will, the ability to consciously navigate the labyrinth of our subconscious mind, to delve into the depths of our dreams with clarity and purpose. The ability to control and manipulate our dreamscapes, to unlock the mysteries of our subconscious, could herald a new era in cognitive science and psychology. Yet, the potential of the Gateway program extends beyond the realm of dreams. The exploration of altered states of consciousness could pave the way for advancements in mental health treatment, cognitive enhancement, and even our understanding of the nature of reality itself. Before we go, let's look at some of the latest research in the field of dream science. Traditionally, dreams were thought to be a way of processing emotions. However, recent research suggests they might also play a role in solidifying memories. A 2021 meta-analysis by Hudacek et al. Reviewed 16 studies on dream content and memory tasks. While results were mixed, they suggest incorporating learning tasks before sleep, then analyzing dream reports and memory recall, could shed light on how dreams contribute to memory consolidation. Lucid dreaming, where you're aware you're dreaming and can control elements, has fascinated researchers. A 2022 study by Voss et al. Explored using targeted electrical stimulation of the frontal lobe during REM sleep to induce lucid dreaming. While more research is needed, their findings suggest this technique has promise for future studies on dream manipulation and lucidity. Dream analysis has traditionally relied on subjective interpretation. However, advancements in AI offer new possibilities. A 2023 study by Xu et al. Explored using machine learning to analyze dream reports and identify emotional themes. Their findings suggest AI could be a valuable tool for future dream research, potentially aiding in understanding the emotional significance of dreams. Dreams have long been anecdotally linked to mental health. Recent research is delving deeper. A 2022 study by Wasing et al. Examined dream content in people with depression. They found increased reports of negative emotions and less positive emotions compared to the control group. This research suggests analyzing dream content could be a helpful tool in understanding and potentially treating depression. While dreams are thought to be internally generated, some research suggests external stimuli can influence them. A 2021 study by Diekelman et al. Investigated the impact of binaural beats, auditory tones that create a pulsating sound effect, on dreams. Their findings suggest specific binaural beats might promote lucid dreaming experiences. More research is needed, but it opens doors to exploring how external stimuli can be used to manipulate dreams. As we stand on the brink of a new era in dream science, one thing is clear: the journey into the world of dreams is far from over. Did this video leave you dreaming of more? Smash that like button and subscribe to Sci Sips for a weekly dose of science that's anything but sleep-inducing.
Alright, Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.